In this recording, we will be talking about testing for a proportion, not for the mean, for the population proportion. So to test for a proportion, we have many ideas. First of all, the population proportion or parameter, we're going to use P instead of mu. And the sample statistic, which is the sample proportion, is going to be P bar instead of X bar. The null hypothesis is the same as we did before. It's going to be the statement that concerns parameter that includes the equality. And the significance level of the hypothesis determines the size of the rejection region, as we did before. And we are going to have either one or two-tailed test, as we did before. We have one assumption must be met before we do the testing for proportion. The sample size has to be, if the sample size n, it should be large in a way that n times p has to be greater than 5, greater than or equal, by the way, and n times 1 minus p has to be greater than or equal to 5. If these two assumptions have met, then the sampling distribution is approximately normal. We can use it with the mean p and standard deviation p times 1 minus p over n under square root. The p is, remember, the p is the population proportion. Okay, so let's do an example. Before the example, this is the z-test, the statistics for the proportion, which is the p bar, it's equivalent to x bar, minus p, which is equivalent to the mu, divided by the standard deviation of the proportion, which is p times 1 minus p under square root, divided by n under square root. So p bar is the sample proportion, p hypothesized population proportion, and n is the sample size. Let's look at this example. In the developmental league, it's for players who are not an NBA rosters but want to fine-tune their skills and hoping to getting called up to the NBA. Suppose one of the teams is considering increasing the season ticket prices for basketball games. The marketing manager is concerning that some people will cancel their ticket orders if this change occurs. If more than 10% of the season ticket orders would be canceled, the marketing manager does not want to implement the price increase. So this is an important piece of information. To test this, a random sample of 100 ticket holders is surveyed. So the marketing manager concerned, he said he will cancel the tickets order. I mean, some people will cancel their ticket orders if the change occurs. What is the change? If more than 10% of the ticket orders would be canceled, this is our alternative hypothesis. If the p is greater than 10%. If p less than or equal to 10%, nothing is going to happen. Nothing is going to happen. Right? So to test this, a random sample, 100 tickets holder is surveyed. This is n, not 16, it's 100. And it shows that x equals 14, the ones who have canceled. So the p bar test is what? Is x over n, which is 14%. So the sample proportion is 14%. Significance level is 0.05. Oops, let me delete this. So we need to test whether this is true or no. Because the marketing manager says if the changes occur, more than 10% of the season tickets will be canceled. Let's go to stats. We have one proportion test. Summarize data. Number of events, the sample, is 14. Trials, we have 100. Number of events is the x value. Number of trials, we have 100. Perform hypothesis testing, 0.10. Confidence level, 95%. Proportion is greater than hypothesized proportion. This is my alternative hypothesis. By the way, this is right tail test. Do we need the exact method? No, we are going to use normal approximation. So what do we have? We have the null hypothesis, we have the alternative hypothesis, we have the p-value 0.091, which is greater than the alpha. Greater than the alpha, that means we are not in the rejection region. We fail to reject the null hypothesis. So the marketing manager does not have sufficient evidence to conclude that more than 10% of the season ticket holders will cancel their ticket orders. We don't have evidence to support the alternative hypothesis because we fail to reject these facts. Okay, and the z-value test we got is 1.33. To compare it to the Z critical, we can just go to graph, probabilities. We have right tail, we have the normal. The mean is 0.10. Standard deviation is, oh, sorry, the standard normal distribution is 0 here. This is 1. It is right tail, 5%. So it's 1.64, 1.645, which is greater than the z-test. The z-test is here, 1.3. So we failed to reject. To get the p bar critical, we have to get the standard deviation. The standard deviation is the square root of p times 1 minus p divided by n, which is 0.1 times 1 minus 0.1 divided by 10, under square root. So we have to this has to be under square root, by the way, cut. So this equals to what? Let's calculate it. So we have equal square root of 0.1 times 0.9 divided by 100. So 0.03. So this is 0.03. So to go back to graph probability distribution, the mean is 0.10. Standard deviation is 0.03. Options, we have the right tail, 5%. So this is our what? This is our X bar critical, which is what? Which is greater than our X, sorry, not X, P bar critical. P bar critical is 14.9%. This is 14%. The P bar test, which is here. So that's why we still fail to reject the null hypothesis. So we used all of the methods to show you that we fail to reject the null hypothesis. The P bar test is less than the P bar critical. This is 14.9. Our P bar test is 14, which is here, percent. Also, the area on the right-hand side of the P bar test is 0.09, which is greater than 0.05. Also, the standardized values for both of them are the same thing. That's it.